Hello, students. Welcome to lesson 6-3. In this lesson, we're going to be talking about how to prove that a four-sided shape is a parallelogram. Now, all of this today, or I should say most of this today, is going to be based on the properties that we were talking about in our last video, the different properties of parallelograms. So remember that our definition for a parallelogram is a four-sided shape that has both pairs of opposite sides parallel to each other, right? So this is parallel to this, this is parallel to this. And then because we know something's a parallelogram, we get four additional pieces of information, right? That opposite sides are actually congruent to each other as well. Opposite angles are congruent to each other. Consecutive angles, the ones along the same side, have to add up to 180 degrees. And that the diagonals, if we were to draw them across the shape, would cut each other in half, okay? Now, each of those properties has sort of a reverse property, or, the converse of the theorem, like we used to talk about in chapters 3 and 4. And that's how we're going to prove that a four-sided shape is a parallelogram. Finding some information out about the sides or the angles, and then using sort of the backwards version of those properties in order to prove that something is a parallelogram. So I'm going to go through the different theorems that this section has, which are all reverse versions of the properties, except for the very last one. And that is the only one that I'm actually going to have you name by its number in the book, Theorem 6-12, but we'll get to that one in a minute. So I don't think you need to write these down quite yet, because there's a table I'm going to show you in just a second that summarizes all of these together, all sort of in one place. And if you want to turn there in your books, you can find that table at the bottom of page 371, okay? So this first theorem is exactly the backwards version of parallelogram property 1. And that is that if you have a four-sided shape and both pairs of opposite sides have to be, if both pairs of opposite sides are congruent, then we know that that shape has to be a parallelogram, okay? We don't actually need to know first that the sides are parallel. If we know that both pairs of opposite sides are congruent, that proves that that shape is a parallelogram, okay? Similarly, if we know that any one of the angles in a parallelogram, in a four-sided shape, we don't know it's a parallelogram yet. Let's say, for example, angle A here. If we know that angle A adds up to 180 degrees with angle B and with angle D, that proves that the shape is a parallelogram, okay? So that's sort of the reverse and a little bit shorter version of parallelogram property 2 about consecutive angles all adding up to 180 degrees. So if for one of your angles, you know that it adds up to 180 with both of the ones next to it, right? So A with B and A with D, and you don't have to worry about angle C or anything else. You know for sure that that shape has to be a parallelogram, okay? So like I said, that's sort of the reverse shortened version of parallelogram property 2. Property 3 is similar to property 1, except we're talking about opposite angles instead of opposite sides. So if you have both pairs of opposite angles in a four-sided shape congruent to each other, so B congruent to D, C congruent to A, if you know both of those pairs, then you know for sure that that four-sided shape is a parallelogram, regardless of what else you know about the side lengths, okay? You know for sure that it's a parallelogram, all right? Now, just also keep in mind that whichever one of these reverse properties we use to prove a shape is a parallelogram, once we know it's a parallelogram, then all of the other properties instantly become true because we know that it's now a parallelogram. Okay, and then the last one that's a reverse property is if you know that both of the diagonals across your four-sided shape cut each other in half. So, for example, here you can see the picture. If we know that BE and DE are the same, right? So that diagonal's been cut in half. Same with AC, if you know that diagonal's been cut in half into two equal pieces. If both diagonals cut each other in half, then you know that that shape has to be a parallelogram, regardless of knowing if sides are parallel or whatever. If you know both diagonals cut each other in half, then you know the shape is a parallelogram, regardless of what else you know. Okay, so those are our 4 reverse properties. Okay, I would simply call them like converse of parallelogram property number 4, right? So that's what I would call these. Converse of parallelogram property 4, and then of course this one would be the converse of parallelogram property 3, and then converse of parallelogram property 2, converse of that, okay? So if we're proving that things are parallelograms, 4 of our options are the converse of a property, okay? The backwards version. We know the property is true, so that means it must be a parallelogram. Okay, this last one, like I said, I'm going to have you just name it like this, Theorem 6-12, okay? That's what we're going to call it. It's the only one in this book that we're going to actually use its number, just because there's no other real good way to name this. But here's what this one says. It's one more way to prove that a 4-sided shape is a parallelogram, okay? And all it requires is that you know 2 things about one pair of sides, okay? One pair of opposite sides, I should say. So if one pair of opposite sides, in this case, BC and AD, if you know that those opposite sides are both congruent to each other and parallel to each other, then we don't have to worry about anything about the other sides or any of the angles at all, okay? We know for sure that that is a parallelogram. If one pair of opposite sides are both congruent to each other and parallel, then we use Theorem 6-12 to prove that that 4-sided shape is a parallelogram, okay? So 5 theorems here in this section to prove that something is a parallelogram. We couple that with the definition of a parallelogram, and we come up with this table of 6 different ways to prove that something is a parallelogram, okay? So here, I think I can fit them all on one page. Yeah, I'll move this up out of the way just a little bit, okay? So we have 6 different ways to do this. Option number 1 is from the definition of parallelogram. Okay, option number 1, definition of a parallelogram, just involves proving that both pairs of opposite sides are parallel. If both pairs of opposite sides are parallel, then it fits the definition of a parallelogram, and that's the way it is. Option number 2 is what we call the converse of property 1. Okay, so I would say converse of parallelogram prop 1. Okay, I would call it that instead of Theorem 6-8. I would call it converse of parallelogram property 1. That would be 2 pairs of opposite sides congruent. Okay, not 2 pairs of opposite sides parallel, but 2 pairs of opposite sides congruent. That's the converse of parallelogram property 1. The converse of parallelogram property 2, remember it's a little bit of a shortened version of the property. If one of the angles is supplementary, meaning adds to 180, with both of the consecutive angles, or I should say, the ones next to it, then we know it's a parallelogram. That's the converse of property 2. We also have the converse of property 3, which would say both pairs of opposite angles, opposite corners, are congruent to each other. And the converse of property 4 would be prove that the diagonals bisect each other. If the diagonals cut each other in half, then we know it's a parallelogram. And then, of course, at the end, we have Theorem 6-12. And that one, again, involves one pair of opposite sides being both parallel and congruent to each other, okay? So, again, in this table, sorry, I got ahead of myself. We have 6 different ways to prove that shapes are parallelograms, right? These are all taking a 4-sided shape, and what we're probably being asked to do in the directions is say, how can we classify this 4-sided shape? Well, if any of these 6 things are true, then we can classify that 4-sided shape as a parallelogram, okay? The question is, what are we going to have to do with this, right? what is this going to look like in our practice problems? And to be honest, a lot of it's going to be algebra again. Okay, a lot of it's going to be algebra. So here we have a four-sided shape, and we're not necessarily told at the beginning that it is a parallelogram, but we're asked what values of these variables, x and y, would make that shape be a parallelogram. Okay, what would make that be a parallelogram? Well, obviously what we have in this picture is the side lengths of our sides of our four-sided shape. So what do we need to be true about the sides of our four-sided shape in order for this shape to be a parallelogram? Well, when we think about side lengths, we should think about congruent sides, and we should be thinking here, right? Converse of parallelogram property. One needs to have both pairs of opposite sides be congruent. So if the opposite sides are going to be congruent, focus on this and this. PQ and SR in this picture need to be of equal length, right? So if I take the length of PQ, 3x minus 5, and I set that equal to the length of SR, 2x plus 1, this is going to lead me to a value of x. In order for this to be a parallelogram, I will need these to be equal. And so that'll lead me to a value of x that would make this true. So, this is an equation that I think hopefully we can solve, move all the x's to one side, 1x, and then we'll add the 5 over to the other side, plus 5, and we get 1x is equal to 6, okay? So x equals 6 is the value of x that would make this a parallelogram. And then there's also a y variable over here, so I need to figure out what that has to be. Well, again, if I need both pairs of opposite sides to be congruent, I need this side length to be the same as this side length. And that means I need y to be equal to x plus 2, right? That's opposite side lengths. Now I know that x is 6, so I'll just plug that in there. 6 plus 2, my y value needs to be 8. Y equals 8 would be the answer here, okay? So most of what you're going to be asked to do in your practice problems for this section are algebra, okay? Algebra. The other thing that you're going to be asked to do is look at a picture and decide, is there enough information in that picture to prove that something is a parallelogram? Okay, so think back to your 6 different methods and decide, does this picture get me any of those 6 methods? If so, you can say yes, and then you'll quote which of our 6 ways to prove. And if not, you just say, no, I can't prove that because there's not enough information. All right, algebra, determining if things are parallelograms, and one proof, 5-step proof. It involves the converse of the same side interior angles postulate. Converse of the same side interior angles postulate is going to be used twice in number 21. So if you have questions about proving that something is a parallelogram using any of those 6 methods, please make sure that you reach out to me. Email, phone, Zoom office hours are all available. Otherwise, that's all I have for you for today, and we'll talk to you soon.